Stop transcription. Okay. Below is the titration curve obtained from the titration of. انسوا السؤال، ما حدا يطلع بالسؤال، اطلعوا شوي على الكيرف. From this curve, can you determine what is the nature of your unknown and what is it being titrated with? أنا من الكيرف قبل ما أطلع الجيفن. Okay, أكيد you have the right to see the given. But before you look at the given, from the shape of the curve, أنا بقدر استنتج بس من هيدي الاريا إنه أول شيء it's weak. تاني شيء you start at a basic pH, so you are basically titrating a weak base. تالت شيء you only have one equivalence point, so it's a weak mono base. From the given, without actually looking at the question, only from the curve. You start from a basic, you go to acidic, it means your unknown is a base, and it's a weak base because of this. Okay, and it's a mono base because you have only one equivalence point. Back to the given. Obtained from the titration of 50 ml of an unknown solution, which contains, by the way, see, they did not tell you, but you know now that this unknown solution is a weak monobase, which contains 0.0851 grams of an unknown base with HCl اللي هو 0.20. You have the grams. Unfortunately, if you have the grams, not the number of mole, you cannot find the number of mole. It means you cannot find the concentration in milligrams, but you can find it from the equivalence point. Okay, so the question is, calculate the pH at the equivalence point, calculate the concentration of the base, calculate the Kb of the base, calculate the molar mass of your base. Okay, basically, in this case, all you have to do is work the graph. Yeah. To find the pH at the equivalence point, you remember this. Draw a tangent, draw another tangent. أكيد these are not parallel tangent إذا بتلاحظوا, so you need to use a ruler. Another parallel tangent. Okay, take the intersection of or the perpendicular of this tangent, and this is your equivalence point. That's basically your equivalence point. So approximately the pH at the equivalence point, it's what? It's around, is on 6. This is not equal. حاولوا انتوا تسووها على الورقة والقلم لأنه for you it will be better. Okay, so let's say it's around 5.7 to 5.8 pH at equivalence. You need a ruler. Okay, 5.8. Good. Thank you. خلينا نعتمد على 5.8. Calculate the concentration of the base. What is the concentration of the base? What's the concentration of the base? بكل بساطة I can also find, بما إنه لقيت أنا ال pH at equivalence, I can also find the V at equivalence. قد إيه ال V at equivalence? 25 ml. So in part B, you know إنه at equivalence point ال N لل A equal ال N لل B. So basically C لل A times ال V لل A, which is basically V equivalence, أكيد at the equivalence point 1, okay, is equal C لل B times ال V لل B. Let's see what I have. I have a C lal A, which is 0.2. I have a V equivalence, which is 25. I have a V lal B, which is 50. Just find the C lal B. Okay, 0.2 times 25 divided by 50. So that's 0.2 divided by half, so it's 0.1. C للB is 0.1 mole per liter. That was part B. Part C, calculate KB of the base. نروح لهون. KB of the base. أنا في عندي point على هذا الكيرف that is very important. هيدا البوينت will tell me the pKa. What is the point? Zakarina, what is the point? Half equivalence pH equals pKa. طالما أنا جبت equivalence volume to be 25, half of it is 12.5. روحوا على كمان انتوا بالمسطرة هون. روحوا على 12.5. Basically it's right here. طلعوا مضروب بنروح لهون. It's what? Around 9.5. So at the half equivalence at 12.5 ml, the pH is equal to 9.5 and it's equal to pKa. Good. If you have a pKa, what is pKb? 14 minus 9.5. Okay. What is Kb? 10 to the power negative pKb. 14 minus 9.5 here, basically 4.5 minus 4.5. Calculate the molar mass of the base. خلينا نكتبها هون. As long as you have the concentration and you have the mass and you have the volume, it's very easy for you to find the molar mass. I calculated that the concentration, the initial concentration of the base to be 0.1 mole per liter. بنفس الوقت I know that the concentration of the base is basically the grams divided by the gram per mole اللي هي molar mass times the volume in liters. Okay, mass is what? Mass is 0.0851. The volume is, what's the volume of the solution? 50. انتبهوا, initial, okay? So not after titration, initial, 50 times 10 to the power negative 3. This is mole per liter, okay? What is the molar mass? يلا, calculate the molar mass هون. What's the molar mass? What? No. 100.2? Really? What's the molar mass, people? ليش فتحت كورتانا؟ Calculator. So what? 0.1 times 51 over 0.0851. It's 17.02. 17.02. هلا. The question stopped. However, it should not. It should continue. Identify what your base is. So, who can tell me what the base is? Who can tell me what the base is? So who can tell me what the base is? What is 17.02? Okay. You can't say that the base is at HO minus. What was the initial of HO minus? HO minus is not a solid. شو كانت قبل ما تصير HO minus? It was sodium hydroxide. It was potassium hydroxide. The molar mass is relative to the solid that you used. Sodium hydroxide, potassium hydroxide. So ما فينا نقول إنه it's HO minus. No, you have to give me a compound. Yes, it's NH3. Okay, good. Move to number 55, and before you even read the question اطلعوا على الكيرف. From the curve, tell me what do you have from the curve. You're starting at an acidic pH. You know you have an acid. You see in this that you have one equivalence point, another equivalence point. It's a diacid. You also see that you have a buffer region here and another buffer region here. It's a weak acid. Why is it a weak acid? Because I have this inflection. So it's a weak acid. Yes. Now back to the question. Consider the adjacent titration curve obtained from the titration of, we have 25 ml of an unknown solution, which is a diacid by HO minus. Good. What is the concentration of the acid in the original solution? What's the concentration of the acid in the original solution? It's very easy to find this, yeah, from the first equivalence point or the second equivalence point. I prefer the first لأنه بالsecond بيصير في عندكم a factor of 2. Okay, remember you have to follow the molar ratio. So in A, you know that H2A plus HO minus بتعطيني HA minus plus H2O. This is for the first equivalence. From the first equivalence, I have that the number of mole of H2A initially present in the solution is equal to the number of mole of HO minus added at equivalence. So the concentration of H2A times the volume of H2A, what was it, 25, must equal to the concentration of HO minus times the volume at equivalence added. So H2A is equal to, what is the concentration of NaOH? 0.1. What is the volume at equivalence? روحوا على equivalence point. Again, ارسموا two tangents, knit two tangents, find the equivalence point, go down, and the equivalence volume is 20. So times 20 divided by, what was the volume of the initial solution? 25. 0.1 times 20 divided by 25, which is basically 20 على 25. So that's 2 times 10 to the negative 4 mole per liter. .08. Check the calculations. معقولي أنا غلطت. Ah, 0.08, yes. Okay, so that's 0.08 mole per liter. Okay, part B. Again, determine the value of Ka1 and Ka2 of this acid. What are the easiest points to use? What are the easiest points to use? By the way, you have two easy points and one that needs a little more calculation. Okay? خلينا نروح على the two easiest points. The two easiest points are basically the half equivalence of the first one, which is equal to pKa1, the half equivalence of the second one, which is equal to pKa2. هيدا الهاف equivalence للسكند اللي نحن بنقول عنه 3VE over 2, and this is VE over 2. Okay, so at VE divided by 2, the pH is equal to pKa1. يلا find it. It's around 2 point, let's say 5. إذا هيدي ل 3 هيدي 5. 2.5 Ka1 10 to the negative 2.5. أكيد you find the value على الكالكوليتر. أوكي ما بتخلوها 10 to the negative 2.5. find the value at 3VE divided by 2. The pH is equal to pKa2, which is equal, let's see home, if you match it أكيد it has to be 30 ml. So at 30 ml, if you go and match it, it's around, if this is 7, so it's around 6.8 or 6.5. Okay, again, use your ruler. Let's take it to be 6.5. It's more like 6.7, but it's okay. So Ka2 to the negative 6.5. This is Ka2 of 6.6. Yes. This is B. C. A solution of NaHA in water is acidic or basic. What is NaHA? بنروح هون. C. NaHA is basically Na plus and Ha minus. Ha minus is an ampholyte. Okay, to find the pH of a solution that has only Ha minus, all you have to do is go pH is equal to half pKa1 plus pKa2, which is half, اتفقنا 2.5 plus 6.6. اوكي نحن نحط هيدي 6 حتى ما حدا يغلط. So 6.6 plus 2.5 over divided by 2 is basically what? 4.55. Yes, 4.55. Is this acidic or basic? So it will be acidic. And that's number 55. Yeah. Moving forward, 56, 57, and 58. 56. In the case of the titration of a weak monoacid HA with a strong base like HO minus, the pH at the equivalence point is what? When you completely titrate HA with HO minus, شو ببين عندكم؟ A minus plus H2O. Equivalence point, it means that these two have completely neutralized each other. So what do you have in your system? A minus. So what is the pH? Basic. Because A minus is a base, it renders the solution basic. 57. Consider the titration of 20 ml of acetic acid with HO minus. Calculate the pH for an added volume of 11.35. And you have the Ka given. انتبهوا. أسهل شيء using X. أسهل شيء using X. Okay, so the V added, the volume of the base added is 11.35. X is basically volume of the base added divided by equivalence. So I need the equivalence volume. How can I find the equivalence volume? Very simply, I know that N at equivalence point is equal to the base. The acid is 20 ml times 0.5. The base is V equivalence times 0.5. So the volume at equivalence is also 20 ml. So X is equal to 11.35 divided by 20. How much is that? What is 11.35 divided by 20? Okay. 0.5675. كيف بقدر هلا الاقي ال pH? It's a mono acid, it's a weak mono acid. pH plus log the is x divided by 1 minus x, لأنه this is between 0 and 1. So it's equal. pKa هي negative log 1.8 times 10 to the power negative 5 plus log 0.5675 divided by 1 minus 0.5675. And this is equal to what? Yalla, give me the answer. It should be a little less. .86 should be a little less than the pKa لأنه it's very close. الأكس شوي أكبر من 0.5. 4.86. Where is it? 4.86. Good. Moving to number 58. Consider the following titration curve of an acid with a base. Okay, I can already tell that this is actually an acid and it moves into a base. Why? Because the pH is greater than 7 at the equivalence point. So I know that it's weak. If you have strong plus strong pH, بتكون 7. If you have a weak acid versus a strong base, على equivalence point حيبين ال A minus, so it will be basic. If you have a weak base plus a strong acid, على equivalence point حيبين ال HA, so it will be acidic. Remember that. So let's see what they. Is it the case of a weak acid? Yes. Why? Simply because at the equivalence point, the pH is basic. وطلعوا, it is basic. Okay, it's greater than 7. So it is the case of a weak acid, yes. Is it the case of a diacid? I only have one equivalence point. So no, it's not a diacid. It's only a monoacid. Okay, so this is a no. The pK is 8.5 أكيد no. كيف دغري عرفتها؟ It's an acid. It's the case of an acid. ال pKa بدها تكون أقل من 7. It has to be less than 7. Okay? The half equivalence هي you go like this. This is your pH equal pKa. Actually, it's not perfectly parallel كان المفروض يكون هيك. Okay? So you have to draw it to be perfectly parallel. So this is actually your pKa. It can be used as a buffer around 3.5. خلينا نشوف 1 2 3.5 3.5 yes. لأنه around 3.5 this is your half equivalence where the acid is equal to the base. So yes, it can be used as a pH as a buffer around 3.5. انتوا بتعرفوا إنه buffer the pH of the buffer has to be close to the pKa. So بما إنه ال pKa is 3.5, yes, the pH of 3.5 is accepted. It can be a buffer around 8. We said no, because 8 is not the pKa. For a buffer, the pH has to be close to the pKa. And this is basically the acid base. Basically, this is the acid base. We only have 52 and 53 left. 52 and 53 will be uploaded as a pre-recorded video either tomorrow or Monday. Okay, and we still have a small idea which is about indicators. Part D. Part D. You know that a buffer needs to have a pH equal pKa. So لما ما بيقولوا لك شو pKa and they just tell you is it a buffer around pH equal 3.5, look at the pH equal 3.5. Look at it. Is it close to the pKa? ما نحن دايما كنا نقول إنه this is the buffer region. Why is this the buffer region? Because in this region the pH is close to the pKa. So yes, around the 3.5 it is a buffer. It can be used as a buffer. This is where your 8 is. This is not a buffer. لأنه بهذه region all you have is A minus. A minus is not a buffer. For you to have a buffer, you need to have both the acid and the conjugate base. وهذا الacid and the conjugate base only exist between the region of 0 and 1, where x is between 0 and 1. Okay, between x 0 and 1 you have an important point اللي هي الhalf equivalence. على half equivalence pH equal pKa, and this is the best buffer. Okay, yeah.